All right, last but not least, 4.2, number 47. Um, 4.2, number 47 asks us to look at concavity, determine the intervals on which the following functions are concave up, concave down, and to identify the inflection points. So I'm going to start off with just a simple derivative of the function f prime of x equals 20x cubed minus 60x squared. And then I'm going to do the second derivative, f double prime of x equals 60x squared minus 120x. So in the past we've done critical points. It's worth noting if you set the second derivative equal to 0, you'll find the inflection points. So funky thing though is I can probably rewrite this in such a way I can figure out what those are. So if I factor out a 60x, multiply it by x minus 2, that would be right. If I set that equal to 0, there's only two possible numbers that could give me a 0 here. That would be 60 times 0 multiplied by anything, right? So x equals 0 is one possible option for an inflection point. Or the other possible option would be 2 minus 2 gives me 0, 0 times that, so x equals 2 is another possible inflection point. To determine if we're concave up or concave down, we really need to test, on either side of these numbers. These are my inflection points. So here's 0, here's 2. So I'm going to pick a number like maybe -1 on this side. I'm going to pick a number on this side of +1. Maybe I pick a number on this side of 3. These are my inflection points. So I need to test on either side. If you remember what we said earlier was our last lecture, we kind of drew these funky faces here. If the second derivative is positive, it's a local minimum. If the second derivative is negative, it's a local maximum, or concave up and concave down. So what I'm going to do is I'm going to do f double prime of -1, because that's on this side. So f double prime of -1, so -1 squared would be 1 times 60 is 60, minus a -1 times this, which is, so it'd actually be 60 plus a 120. So this is going to be a positive 180. Then f double prime of a 1. So 1 is 60 minus 120 is a -60. And then f double prime of 3. Let's see here. 3 squared is 9 times 60. It's a large number. Keep my annotations here for a second. I have to actually break out a calculator almost here. So 3 is 9 times 60 equals that. And then we're going to subtract out 360, because 3 times 120 is 360. So subtract out 360, I get a positive 180. All right, go back into my slide here. So this is a positive 180. So what that means is at -1, the second derivative is positive. So therefore I am concave up. This is what the function's doing. Really, at -1, that's what it's doing. And then when we get to 1, it's negative, so now it's concave down. And then at 3, it's positive. And what these inflection points really do for us is they kind of give us what's going on here. Go to a different pen color here real quick. Let's go to something bright blue here. So really, nothing happens until I get to this inflection point of x equals 0, is when I switch. That's what inflection means, is I switch from one concavity to the other concavity. So from -1, probably to infinity, essentially I'm concave up something like this. And when I get to 0, so this could go on forever for all I know, because there are no other inflection points. When I get to 0, that's an inflection point where I shift to concave down, like this. And then 3 represents my next inflection point where I switch back to concave up. And that goes on forever. So these are your inflection points here. Your -1 really was your critical point that determined your concavity here. And your, let's see here. Oh, excuse me, not negative. Actually, I guess it's not -1. Yeah, really it's not necessarily -1 as a critical point. It's just a number on this side is all it is. As long as that's positive, we know it's concave up. This one's positive, we know it's concave up. So any number on this side. So actually the inflection point was at 2. So let me fix this real quick, because this is a little bit off. I'll go to pointer options, eraser. Gotta be careful where that inflection point was. So remember that inflection point was actually at 2. So that's where I actually turn the corner and come down like this. And what I've actually done is I've checked it at 3 right here for the second derivative, and that determined that it was concave up. So hopefully that helps out on 4.2 number 47.